Okay, so today I'm going to talk about simple simple glass or magnifying glass, right? So now what is it? Magnifying glass, right? So first of all, moving ahead to discuss it, one thing that I would like to discuss with you guys is that we know that for a small object, I would say for small object to be seen clearly. I'm talking about without using any sort of electronic instruments, without seeing any object. For a small object to be seen very clearly, the object should be placed at a distance of should be placed at a distance of 25 centimeter from an eye. Right, so here we can see in an object clearly called a distance, which means dur, and distance, right? So this is a minimum distance through which you can see an object clearly. For instance, for a while you can perform the experiment at your home as well. Not experiment, this is some sort of activity. For instance, let me take a marker and explain you with that. For instance, for a while you can see that this is a pen. Now bringing it at a distance of 20 centimeter, 25 centimeter from your eye, you can see it clearly, but bringing more closer to the eye, it would eventually get blurred, right? So this is the minimum distance through which you can see an object clearly. Now what exactly the phenomena behind it? Right, so let's just discuss it. For instance, wait. Okay, so let's see. For instance, this is an eye, right? This is an object. The angle subtended by eye or by object on a eye, right? For instance, let's just ignore that eye. For instance, the angle subtended by an object on eye, right? It's known as visual angle. This is something that is subtended by an eye on an object. This is a visual angle. So you can here make an angle theta. So this is object, height of object. This is a visual angle, right? So the height of an object to a visual angle, on the angle, the you know the this is basically height of an object. This is an eye. So the ray subtended by an object on an eye is known as visual. Let me check it. Like yeah, the angle subtended by an object on eye is known as visual angle. Right. For instance, now the object is placed at a distance like this, and your eye is placed here. Now you can observe it by your own self. It's like subtended and ray. This is an angle. Right. Now you can see that this visual angle is large. So increasing the height of an object, the visual angle gets increases. So this is the ultimate relationship that we can draw through it. Is that let's just not disturb this. Wait. Okay, so let's just take this marker. Okay, so we would say that height of an object is directly proportional. Height of an object is directly proportional to the visual angle. The more the visual angle, the more the height of an object. So there are ultimately two ways for increasing the height of an object, height of an image. The height of an image, the height of an image can be increased by two ways. The first way is to increase the height of an object, to increase height of an object, and the second way is to increase the visual angle. Ultimately, increasing the height of object, the visual angle increase. To increase the visual angle, right? So yeah, okay, we are done with it. Height of an image and to a visual angle, right? The height of an object is directly proportional to theta, and more the height of an object, the more the visual angle is, right? So now just moving to ahead to discuss a formula here. The formula is quite simple, which is like magnification is equals to beta upon alpha. Now I won't be writing a long beta definition here. I just like telling wobbly. So beta is basically a visual angle subtended by an image, right? So the beta is a visual angle subtended by an image, while alpha is a visual angle subtended by an object at a distance d. Now what is at a distance d? At a distance d is a minimum distance through which you can see an object clearly. For example, this minimum distance is equals to 25 centimeters. So this is the distance through which we can see an object clearly. So this is basically a visual angle subtended by an object at a distance d and triangle subtended by an object, an image. So this is basically a formula of magnification. What if you want to increase, for instance, now you want to increase the size of an image, like you can see an image magnify only at a distance of 25 centimeters. You want to increase the size of an image, but not more than, you want to increase it more than 25 centimeters. So what's the exactly solution we have? That we have is magnifying glass or a simple microscope. Is basically it forms an image at the point D where we get the maximum magnification. Where alpha angle has to do nothing with it, only beta angle gets increased though it's small in nature. So next lecture we'll discuss about the magnifying glass. Yeah.